Thanks. My name is Tobias. I'm from a company in London building a big data analytics platform called Velo. Might have seen our stand down there. I'm here to talk about our experience in building this platform. So, first a bit about Velo. Velo is both real-time and historical data analytics tool where we focus on simplicity. Not simplicity from an algorithm point of view, but simplicity from a user's point of view. So very easy for the developer to use, very easy for the admin and the DevOps. It's a single process which contains the time series repository, a semi-structured repository, the execution engine, everything you need for the clustering. The whole application is written in Scala with some parts in C++ and Lua. The whole system is REST-based, so you interact with the system via REST, and you do put and post and delete commands. So in this example, we're creating an air sensor stream. A stream is just a URI, and here we put the schema. We just define the schema as a sample time, sensor, and pollution, and then you can post data. And that's how simple it is. It's very data-friendly. So when you're posting data, you can post data in JSON, CBOR, CSV, binary JSON with YAML, we have VBOR. And you can decide to just have this as a real-time stream, or you can then store it in the historical repositories, which is either a time series repository or a semi-structured repository. When you come to consume the data, you can both consume it historically or in real time, and the exact same query can be used. The only difference is the historical keyword. The language is SQL-like. It's not a strict SQL standard, but it's a set of transformations. So that's basically Velo, and it looks very simple, but trust me, I got 15 years of development in the finance industry, building P&L and risk systems, and building something like this from the ground up, it's not easy. These are just some of the things, concepts, and technologies you might have to deal with. And there's a very big difference building an analytics platform as a single node framework versus building a clustered framework. But it really comes down to three things. If you start building something like this, these are the things you need to consider. You need to consider your cluster management, your data distribution, and your distributed algorithms. Now, most people, when they think about an analytics platform, they will start with algorithms. This is what I need, this is the algorithms I need to run. And you often run into problems when you then start to scale this up. It might be easy to run on a single node with a few gigabytes of data, but as soon as you hit terabytes of data, your system is likely to fall over. So the first thing when you're building something like this is to consider your cluster. A cluster is a set of hardware or set of servers connected over a network. And often these servers are commodity hardware, and they're likely to fail. You just accept this is how it is. And often, or sometimes, you have unreliable network. So you can imagine in a big analytics engine, you have some nodes, some hardware that keeps on failing. They drop off your cluster. You have dropped messages, you have delayed messages. The node might process the message but never responds because it's crashing when it's processing the message. You can also have split networks. So if you have a big cluster, hundreds of nodes, and your network basically splits in half, you end up with two working clusters. And then you have issues with mutable state in there. You have two users or multiple users using each part of the cluster. And when the cluster heals, you end up with issues with the state. Now, when you build something like this, you just have to accept it. This is how it is. And this is what drove the big NoSQL databases and that whole thing. It's like, just base it on commodity hardware, just accept that things will fail. And this is why it's sometimes difficult to use things like relational databases and scale it properly, because you're running into issues with transactions, etc. So what you need to do is your cluster, you make sure that there's no single point of failure. You don't have any leaders, you don't have any master-slave setups, you don't have any special node. A node in a cluster behaves and looks exactly the same as its neighbor. Then there are things that you can use as a developer. One of them are CRDTs, conflict-free replicated data sets, which are fantastic for counters, for sets and stuff. They are eventually consistent. You don't care if your counters will be correct now or in 5 seconds time or 10 seconds time, they will be eventually correct. For the rest, base it on vector clocks. This is basically, it's an old concept, but it's really driven home by Amazon Dynamo. They were using vector clocks heavily to guarantee that you can have multiple updates or simultaneous updates to a document or to a resource. You have a conflict, and that conflict is not resolved until you read the data back. So then you can handle split networks, you can handle nodes going down. So you have sorted out your cluster, you have proven that you can have a cluster of hundreds of nodes. Then it comes to the data. If you are running on a regular Hadoop cluster and stuff, the data, it can just consume a lot of data, but often the data is just spread out. Now, if you do, if you're going to be serious with big data analytics, you really need to understand the data you're storing. You should not store time series data in a semi-structured repository or the opposite. Try to squeeze time series data into a semi-structured repository, and also you might have a key value repository. So in Velo, we have all these three. There are three distinct repositories. So in this example, we store in time series repository, you store CPU data, market data, ECG data, and in the semi-structure, you do where you need to search data based on terms. So you store log files, emails, documents. Now, what it comes down to really, imagine you have your cluster, you have hundreds of nodes. And what really matters with a big data analytics platform is how do you put your data and your replicas of that data in the cluster. You can just randomly distribute it in the system, and that's perfectly fine to start with if you're building a key value store. But really, if you're dealing with, as we're doing, working against the financial industry, and you have regulatory data you're storing, and market data, you really want to have resilience. That means that you don't store the data, your replicas, in the same rack, in the same hardware. But at the same time, you want to have some locality. If I'm doing a time series analysis, I really want to use the resources as much as possible, so you really want to make sure your replicas are sitting on the same physical hardware. And at the same time, you want to make sure when you grow your cluster, when you add or remove nodes, you don't want to shift a lot of data around. If you're sitting on terabytes of data, and just because you're adding a single node to the cluster will send around lots of data. You want to avoid that. At the same time, when you come to run queries, you only want to hit the node in the cluster which holds data. So there are lots of things here to think about, and this, what I have here, is often more important than the actual algorithms they're running. If you don't solve this, you will have a serious problem later on. What we're using, what we're basing this on in Velo is, first of all, consistent hashing. It basically gives you a hash that doesn't change a lot when you add new nodes to the cluster. So if I increase the size of my cluster with a few nodes, maybe just 5% of the data will have to be sent around in the cluster. And also, another very important thing is you distribute the data in the cluster based on time policies. So if you compare to a key value store will just hash the key and then put it somewhere in the cluster. With streaming data, what you should really do is you see your cluster as a continuous set of servers, and you go like, okay, the first second here, the second second here, and the third second there, or you can do by day or by hour or by minute. So when you come to do queries, you can optimize your analytics by running it over a contiguous set of data. This is just an example here where on the left, the data has been distributed somehow randomly, and on the right, we're trying to put the replicas close to the primaries, but still on different racks. It's just a very simplification of the problem. But what you end up on the right-hand side, I can use 3 nodes instead of using on the left, using 4 nodes to do the computation. Now, when you got your cluster in place, you got your data distribution in place, then you need to look at your algos. And in Valo, this is a very simple query where we just calculate the average of the kernel metrics from a CPU stream, and we're running this historically. Now, you can run this query very naively by bringing all the data from your repositories up into an execution engine and calculate it there, which is fine if you got hundreds of megs of data, or maybe a few gigs, but not when you have terabytes of data. So you start looking at, okay, you need to break down my calculations. So you can see this as a directed acyclic graph, where you do partial calculations down where the data sits. So these partial calculations happens as close to the data as possible, and emerges or only sends the partial results up to a single point where you do the calculation. This is fine, but you still have to bring the data up from your repositories. So really then what you need to consider is to push the data or the algorithms all the way down into the repositories, into your time series repository, into your semi-structured repository, so the data does not leave the repository at all. And then you can optimize things. If you have a pre-calculated index, you can push that down. And this is the kind of stuff that Valo does. Valo will take a query, it can be arbitrarily complex. It will break it down into an acyclic graph and optimize it where it can. Now, in Valo, you can write your own algorithms, and it comes down to an interface like this, where each algorithm, we call them streaming algorithms, online algorithms, where you have init, apply, a reduce, and a finalize method. And it looks very simple, but it buys you so much. If you write your algorithms this way, you can completely distribute them. You can take the part that matters and run it down in the repository. You can handle failovers. I can store the state of an algorithm, I can store it, shift that over to another node in the cluster, and continue the calculation there. So on the right hand here, we have, that's just the implementation of the average double. It has apply, reset, merge, restore, get result, save. And these are zero memory algorithms. They don't hold any state except for, it doesn't hold any buffers. They only hold the state, and it can calculate as fast as you can process the data or send the data in. Now, this is fine for most of the algorithms that you can break down, but there are certain algorithms which you would never be able to break down in this way, and they are path dependent. So, for example, if I do a gap filling, which we're doing for market data, if you want to ensure that you have a price every second in your market feed, sometimes what happens is that if you get data from Bloomberg or Reuters, you're missing some data points, and you need to gap fill that. You need to fill that value. And you can't fully distribute this in an easy way, but what you can do, if you write your algorithms correctly, you can do what I'm calling here traveling algorithms. So instead of sending the data around, you send the algorithm around. So, and this comes back to, if you distribute your data correctly, and it's not just randomly in your system, but you have distributed the data based on a time-based distribution, then you can take your algorithms, actually jump from repository to repository. So you do the first part in one repository, you store the state, and you go to the next repository. So the data never leaves your repositories. It's only the state of the algorithm that travels around as fast as it can. So that is, if you consider building your own analytics platform from ground up, you can use Spark or Flink or whatever, but if you're crazy as us and want to build it from ground up, our takeaway, or what I want to say here, is that make sure you focus on these 3 things: the cluster management, the data distribution, and the distributed algorithms. So that concludes my talk. And if you want to see more, if you want to see how Valo works, we have a stand down in the corner of the hall, and we can do a demo. We have a UI that we can visualize this or demo it for you. So that's my talk, and thank you.